Okay, so we're going over solving quadratic equations, and this question asks us to find the value of the coordinates of the vertex. Alright, first thing we got to figure out is actually which form this is in. Okay, so there's three forms: standard, factored, and vertex. Which of the three forms is this quadratic in right now? What has two brackets? Yeah, it's in factored form. So we have factored form here. And what we're going to do is we're just going to pull together some of these things so we make sense of it. The R and the S are actually our coordinates for the x-intercepts. And our A, which is the same A in every single question, is the number 4, whether it's in standard form, factored, or vertex form. Now, since there are coordinates of the x-intercepts, x-intercepts are when y is equal to 0, so we're going to set each of those brackets equal to 0. Okay? 0 equals, we don't actually have to put the bracket in. So when I move it over, our two values of x-intercepts are x is 2 and x is negative 6. So if we're trying to make sense of this now in terms of a graph, we're going to make a small graph here on the side. We have one point at negative 6 and another point at 2. Okay? Now, the x value of the vertex is going to fall where? Is it going to be outside of these or in between them? In between. Where in between? If it's a symmetrical shape, where would it probably fall in between? Do you know what that means? It's directly... It's a parabola. It's directly in between. It's the middle of them. Okay? So those 2 points, it makes it easy for us to find out what the x value of the vertex is because it falls directly between them, right in the middle of those 2 points. So they actually use a formula for it. It's called the axis of symmetry. It's also the x value of the vertex. Okay? So what we're going to do is we're going to plug it into that formula. That formula says r plus s divided by 2. Well, these are our values of r and s, okay, for our axis of symmetry. Axis of symmetry formula. So r and s are 2 and negative 6. So negative 6 plus 2 divided by 2 gives us our AOS, I'm going to call it. Negative 6 plus 2 is? Yep. Divided by 2. Good. So what we just discovered for our vertex, we know the x value of it. The x value of the vertex is negative 2. What we need to find is the y value. Okay? So we have the x value of this. How can we figure out what the y value of this is going to be?
Sub it in.
Yeah, we'll sub it into what?
That.
Yeah, into our original equation, right? Mm-hmm. So we take the original equation, f at x is equal to 4, x minus 2, x plus 6. And because this is the x value, we're going to sub this in for the x's in the equation. So we're going to take negative 2 and replace both of the x's. And in function notation, what that kind of looks like is f at negative 2, right? Because there's so many different x values we could plug in. This way we denote what we're using. 4, negative 2 minus 2, and negative 2 plus 6. So we'll deal with what's in the brackets first. Negative 2 minus 2 gives us negative 4. Negative 2 plus 6 gives us positive 4. And a lot of times the axis of symmetry, when we plug it into our factor form, it's going to give us a positive and negative value of the same number because it falls directly in between. So now we have 4 times 4 times 4, and it's 4 times 4 is going to give us negative 16 times positive 4, which will still give us a negative number. Do you know what it's going to be?
64.
Yep, that's what it is. Okay, so that's the y value. Oops, 64. So what that means is, sorry, it's a negative 64, is it not? Yeah. So our vertex is at negative 64, which makes sense. So let's say for some reason this is negative 64, and here's our point. So we're going to have some parabola that opens upwards, and we already knew that because our a value was a positive number. So we know this makes sense. If we have a vertex below the 2 x-intercepts, these are 3 major points along that parabola. Yes. So when they talk about axis of symmetry, especially if they're asking for a equation for it, axis of symmetry is technically a line, and we know how to make equations of a line, right? So this is a linear relationship, but it goes vertically, up and down. And in this case here, it hits what x value? Negative 2. Okay, so the x value for the axis of symmetry is negative 2. While since equals directly straight up and down, the actual equation of this is x is equal to negative 2. Alright, another question is asking us for the maximum height of a football. This is modeling a football being thrown into the air, and they want the max height. Well, first of all, I got to figure out which form this is in. And when I look at them, I don't have two sets of brackets, so I'm probably not factored. And then, in fact, I don't have one set of brackets squared. So this looks kind of like standard form, but the only thing is it's a bit backwards, right? So what we're going to do is we're going to rearrange it. Now, what I mean by that is technically my a value is the coefficient in front of the variable that's squared. So my a value is actually 4.9. My b value is the value in front of just the x to the power of 1, which in this one would be 28. My c value is the constant, which is 2. So I'm going to rearrange that so it looks a little more like standard form. H at t is equal to negative 4.9t squared plus 28t plus 2. Now my a is a little easier to notice, my b still in the middle, and my c are constants on the outside. Now, I could factor, but the fastest way would actually be to put it into vertex form, which is this form here. Okay? Putting it into vertex form is what we need to do is complete the square. So, in completing the square, the first thing I want to do is divide the first two terms by the a value. The a value in this one is negative 4.9. Okay? So when I do that, I'm going to get negative 4.9 on the outside, t squared. And then positive divided by negative gives me a negative. So 28 divide negative 4.9. What we're going to end up with is actually a fraction. Okay. Now I have a decimal, but it'll probably be easier if I work in fraction form here. 28 divided by negative 4.9. Okay. Brackets plus 2. Okay. At this point, what I'm going to notice is, in completing the square, I'm going to be working with a relatively difficult number. It might actually be easiest if we work with the quadratic formula to find the x-intercepts. But either way, we can work with it. Now, whether I want to put this as a decimal or fraction, it's up to you. I like working with fractions because I can usually kind of do most of the stuff in my head. This one I won't obviously be able to do everything. So let's move down here. Now, the next step to this, the next step here is we have a little formula b divided by 2 squared. So this is our new b value. Okay? And a new b value is negative 28 divided by negative, well, that shouldn't be right, divided by 4.9. Okay? Now, if I make it a decimal, which we had over here, it's negative 5.714, we could say. So we're going to do both here, just so you see they're similar numbers. Negative 5.714 divided by 2, and then we're going to square it. So I can divide this by 2, and then square that number, and I get 8.163. And I have to add or subtract this number to it. Does this look familiar to you? So I will add and subtract that number into the brackets here. So I get negative 4.9. So this is a much more complex one. T squared minus. I'm going to write this in as its decimal form. 28 divide 4.9. It's because it's such an odd fraction anyways. Minus 5.714. There is a t there. And we're going to add and subtract 8.163 because we're completing the square, and we'll go over that again in a second. So I'm going to add 8.163, and I'm going to subtract 8.163 inside these brackets. Now, what I need to do is I need to move the negative term to the outside of the brackets. And when I do that, I got to multiply by my a term. So I'm going to have to multiply that by negative 4.9. Okay. So I'm going to take that value, negative 8.163 negative times 4.9 negative. 39.9987. We could probably round this to 40. Okay. So it won't be dead on, but we're going to be relatively close. So what ends up happening here is negative 4.9 t squared minus 5.714 t plus 8.163. So that's still all inside the bracket. These were these terms here. I just brought them back down. This term is coming outside of the brackets. And it's now, we rounded it to positive 40 plus 2. Okay. Now we're starting to get our vertex form. If you notice, in our vertex form we have an a. Well, here is my a value. A k is going to be outside of the brackets. That's what this is going to be when we add it. So it looks like it's going to be 42. And then I just need to factor what's in here. Now, obviously I could use quadratic formula or I could factor myself, but we're working with decimals, so it'll be a little harder to do. But the good thing about completing the square is the goal is to set this up so that I can actually kind of cheat my way through it and just square root the first and last term because it's a perfect square trinomial. That's what we made. So, the square root of t squared is going to be t. Now, the square root of 8.163. Well, if you take a look, 8.163 square root 2.85, which is actually what 5.714 divided by 2 is. So 2.857, we'll say. 2.857. And what's going to happen now, and on the outside we have plus 42, I'm going to take my terms. My t is the first term. My second term is what my square root was, 2.857. And I actually bring down whatever term was in front of our middle term here. So I bring on the operation of a negative sign. So now I'm left with negative 4.9 t minus 2.857 squared plus 42. Now we rounded the k value. Now I want you to recognize that this is in vertex form. So because it's in vertex form, they're asking us for the vertex. Well, our vertex is our h and our k value, right? Here's our h and here's our k value. So it looks like the highest the ball went was roughly 42. We use our x and our y values for that. The ball is roughly 42, and it was at that height at about 2.8, 2.9 seconds, I think it's measured in. We'll round it to 2.9. seconds, and it's roughly rounded to 42 meters. Okay. Now, even though this is very complex, it's actually the fastest way to find the vertex is by completing the square. Okay, we're going to complete the square of this question, and we're actually going to try to use algebra tiles. Now, even using algebra tiles, the first thing we do got to recognize is we do need to divide the first two terms by whatever the a term is. What is the a term here? Yeah, negative 2. So I do need to take negative 2 out of both of these. Okay. So when I do that, it becomes the a term on the outside of the brackets, and I'm left with x squared minus 8x, okay, plus 10. Now this is where the creating of a perfect square trinomial kind of comes into place here, and we're going to try to make sense of all this here. So I've taken my negative 2 outside. So let's think of this right here. I have an x squared, which is going to be represented by this. Negative 8x, well, if this represents a positive x, each of these is going to represent a negative x. So I'm actually going to need 8 of those. And 10, which we're going to use to represent this as 1s. Okay? So I'm going to bring these shapes over. So we have an x squared, and we have 1, 2, it's going to take 4, 5, 6, 7, 8. And of course I do have the 10 ones. I should have made that a smaller number. Finally 10. Okay. So all these blocks are representing what I got there. We're kind of keeping this to the outside as our term that we got there. Now, when we say completing the square, what we're actually trying to do is build a square. Okay, so that's the reason I've kind of split these in half. I know I have 8. I'm going to attach them to my x squared and try to start to create a square out of this. Okay, so these aren't really a part of it; they're just manipulatives, and we're going to hold our 10 ones to the side for now. So when I'm doing this, I'm going to move negative x. So I got 1, 2, 3, 4. Okay, so I put 4 on the top, and I'm going to put 4 on the side. I'm just going to pause this while I turn them. Okay, so we take our 4 tiles now, and we're going to move them in the kind of the same direction that we did the other ones. Okay, 3 and 4. Now, while we look at this, I'm trying to actually build a square. So right now I actually need to fill in this space here, right? To make this into a square. That's what they mean by completing the square. Well, in order to do that, 1, 2, 3, 1, 2, 3. How many small pieces am I going to need in order to create that? It's a 4 by 4 row, it looks like. 4, yeah, by 4. We're going to actually need 16. And that's the idea of what we were doing over here when we would divide this, b divided by 2 squared. We're taking that 8 term, negative 8 divided by 2, gives us negative 4 squared, gives us 16. Now I need to fill in this 16, all right, to actually build a square. That's the goal here. We're trying to build a square. So I have to add and subtract 16. And that's when we go to put it in the bracket. So to add and subtract 16, I actually have to take 16 of these 1s here. And I have to do of the positive version. I'm just going to pull 4 out and duplicate them. I'm going to need 16 of the positives and 16 of the negatives. So give me a minute. Okay, so what you can see I've done here with the tiles is I've actually added 16 tiles, and I've also brought in negative 16 tiles. Okay, so what I'm going to do now is I'm going to add these 16 tiles into this spot here. And this is what is going to complete a square. I now get the shape of a square in here. But I still have the negative 16. All right? It's just kind of sitting there. It's, if you look when we move it over, it's to the side of it, not really included in our brackets. And this, right now, we're talking about everything in these brackets. Okay? That's what we're talking about, everything in those brackets. So I've added and subtracted 16. So what that kind of looks like when we go through completing the square is x squared minus 8x. Remember, we add 16 and we subtract 16. But in order to factor this, and I'm going to factor it by just figuring out how long these sides are, this is extra. I don't need it. I need it to come to the outside. But when I bring it to the outside, remember I have an a value of negative 2 here. And due to distributive property, this negative 2, sorry, let's write negative down there. That negative 2 actually needs to be multiplied by every term inside due to a multiplication rule of distributive property. So when the 16 comes out, it actually has to be multiplied by negative 2. So when we finally pull those 16 out, they become what number? So this is, think of it like negative 16 times negative 2.
Positive 32.
Yeah, positive 32 would come out. Okay. So what that looks like over here is negative 2 x squared minus 8x plus 16, positive 32, and what about these guys here? They were kind of left to the outside. Remember we were adding them? That's our plus 10 on the outside. Okay. Now the completing the square part helps us with the factoring. We know now that we have 32 plus another 10, we're going to end up with 42 as a k value, right? We have 42 out here. And we still have x squared minus 8x plus 16. Oops. Now, I could square root everything, but this is what I want you to look at. I'm actually looking at the distance of this and the distance of this. Okay. Now, in terms of distance, if this area is x squared, the distance of this side is x, which would also mean the distance of this side is x. Okay. And because these are negative, each of these, if you look, is the distance of 1 in terms of these blocks. So I have 1, 2, 3, 4, and they're all negative. So I have a distance of negative 4. And again, same idea here. This is 1, 2, 3, 4. Another distance of -4. So, keep those numbers in mind, -4 and -4. When we're actually doing our factoring here, we square root the first and last term, right? We get -2. Square root of x squared is, square root of 16 is, and we bring down the middle term, so we have and it's squared. And the reason it's squared is because I have a bracket of x minus 4 and times another bracket of x minus